Okay, so a computer is basically made up of two main modules, which is, consider this as a computer, and this is the CPU, and this is the memory. So, if we look at computers, it is basically two main modules working, uh, which gives us the desired output or input or whatever work we want our computer to do. So, if we consider computer as a wider perspective, there are two important modules, that is the CPU and the memory, which I just told. The capability of a computer to process large data is dependent upon these two modules only. Computer is dependent on these two components of only. How strong is your CPU, that is your logical engine, and how large the memory is, because to store large data for computation you need large memory. So there are basically two criteria for any memory. Two criterias. See, two criterias. First one is the size, and the other one is access time. Size is of course how big your memory is, how large data can your memory store, and the access time is how long does it take for any particular data to be retrieved from that memory, or rather I should say how long does it take for any data to be retrieved by traversing through the memory. Okay, so now we talk about the constraints of these two criteria. First one is the size. You cannot have large sorry so let's talk about the constraints of these two criteria. Number one is the size. What we want from our computer is a large storage capacity. So we want size bigger, we want a bigger size for our computer, and the time taken to retrieve any data from that storage should be very less in order for efficient working of our computer. So access time should is desired as less. But as you see, these criteria cannot be met contemporarily. No memory can have all the two criteria met at the same time, because if the size is big, you need more time to search for an item into the memory, thereby increasing the access time. Also, if your memory size is big, per unit memory cost would also go higher. So that brings us to the third criteria, which is per unit cost. We will basically ignore this third criteria because it doesn't fall under the operating systems category. That is completely a financial aspect. So in a computer system, to eliminate the above constraints, we have something called hierarchy of memories, which is, instead of having a single memory, we have different kinds of memories arranged in a hierarchical pattern which perform different tasks. All these memories store data but have different roles in accessing a particular data. There's a concept called locality of reference. A program. Now let us understand this through a program, through a set of instructions. See, a program executes subsequently. Suppose this is I1 instruction 1 and this is I1000. This is instruction number 1000. So in while executing this program, our computer would go sequentially. Our CPU would execute each instructions sequentially. So it would go like this. First number instruction 1 would be executed, then instruction number 2, then instruction number 3. Similarly, it would follow the same pattern and reach instruction number 1000. Now suppose we want to execute instruction number 200 somewhere in between, and we want to do it instantly. We don't want to be executing all the way from I1 till I200. We want it to execute uh, instantly. So what we do is we want to skip all the other instructions and bypass the other instructions. In computer programming, there are statements like go to, if else, which do the same job, but uh, normally the CPU executes all the instructions before it reaches the instruction of desire. Thus it increases our access time. So to overcome that, we have something called hierarchy of memories, which I already told. So to eliminate such constraints, we take a certain part of the instruction set, which is the entire program, a certain part, let's say this part, the the immediate predecessors or the successors of instruction number 200, which is our desired instructions, which we needs to be executed, and we take this part of the program, this part of the instruction set, and move it to a different memory instead of the secondary memory. We move it to this different memory, and the size of that memory should be very small. Let's keep it very small, so that our access time of any data from that memory is very small. So now let us understand how hierarchy of memory works. Suppose this is the bigger memory, the secondary memory. Which is basically the hard disks or the uh, SSDs on your computers or laptops. Then we have something called main memory, which is the main memory, or which is the main processing area of any data. Main memory. People also call this as RAM, which is the random access memory. Its size is very small compared to the secondary memory, and thus the access time for this memory set is also very small. Then we have something called cache memory. Its size is even smaller than the main memory, and it is used for very fast calculations. It is the fastest memory available in a computer. And then we have the CPU processing all our data. So this entire set is called hierarchy of memories, or and the concept of locality of reference is was just explained here. We take the local instructions of our desired instruction set and then place it in the main memory. So in computer, in operating system, we would only be talking about main memory and the secondary memory and the CPU. Cache memory would be excluded because it is beyond the scope of operating systems. It falls under the subject computer architecture. Now we place this data in the main memory in such a way that the hit ratio is over 90%. That is, 90% of the times if we require to execute any instruction, it is available in the main memory. The rest 10% data can always be looked for into the secondary memory. This is same like an example, for example, this is same like shopkeepers and his shop. A shopkeeper keeps all the important articles in the shop for itself. Articles that the customers ask for 90% of the time. If any customer asks for any other item, the shopkeeper can always run to the go down in the runtime and fetch it from there. Similarly, in a computer system, main memory acts as the main shop where all the frequently used data is stored, and the secondary memory acts as a backup. So with this concept, we can significantly reduce the access time of our data without actually having to compromise with size. And similarly, the same concept could be replicated with cache memory. The frequently used data in the main memory is kept in the cache memory, thus further reducing the access time. Cache is never a single memory, but further consisting of different levels. Normally, cache level 1, cache level 2, and cache level 3. That is, level 1, then level 2, then level 3. See, level 3 is the fastest memory available under cache memory. Now let us take a numerical example and calculate the average access time of the main memory of any of our computer system. So let's assume that our secondary memory has an access time of 100 milliseconds for secondary memory. And the access time for our main memory is, let's say, 10 milliseconds. And that is for the main memory. And the hit ratio is, let's say, 90%. This hit ratio denotes that 90% of the times, if you are looking for any data, it would be available in the main memory. Okay, so let me draw the diagram. This is the secondary memory. This is the main memory, and let's say this is the CPU. We are ignoring cache because it doesn't fall under the scope of operating systems. So its access time is, say, it was 100 milliseconds. Main memory's access time was 10 milliseconds. Now we have to compute average memory access time, and the hit ratio given is 90%. So average access time is, now the hit ratio is 90%. That means that 90% of the times we can find our desired data in the main memory. So 0.9 times, and its access time is 10 milliseconds. So 0.9 times 10 plus, now we have 10% of the times we have to go into the secondary memory to search for the rest 10% data. So 0.1 times. So we also have a penalty of 10% penalty on that 10% data, because to access that other 10% data, we are going back to the secondary memory. Okay, so that penalty of 10 milliseconds plus the access time of the secondary memory, which is the 100 milliseconds, now it sums up to 9 plus 11. Yeah, so average access time is 20 millisecond. Now see, if we used only the secondary memory, it would have cost us, cost us 100 milliseconds, 100 milliseconds of time. That is a lot of time. But using the hierarchical structure of memory, we got our data in only 20 milliseconds, which is an enormous reduction in access time. So this is, guys, how memory works in computers. So this was all about basics of computer memory, and thank you for listening to me, and thank you very much.